Okay, so welcome to class, the two of you that came. Uh, so I'm not going over anything really HPCE today, but I thought it would be good to go over correct memory handling in C++, because it's actually an extremely difficult task. Because C++ doesn't sugarcoat anything, and so you have to do it all yourself. Let me see here. The project is due on Saturday, so I'm pretty sure I've given you everything you need to get that finished. Again, keep me posted, email me, let me know how things are going. Tomorrow, I'm planning on actually going over the next project. I just have to finish up some stuff today before I can actually teach you how to do it, because I got to do it myself. So, there's that, and that will be the last project I'm planning on making. That will be the last project. It'll be due probably 2 weeks from Saturday, so end of July sometime-ish. And then there will be a final extra credit project that was optional. And we'll get to that when we get to that. So this is a really long lecture. I've spent a few hours putting together a lot of slides. And we haven't even gotten to the good stuff. We got to make it through all the preliminaries first. So anyway, let's go ahead and get started, I guess. Okay, so memory management. In C++, you are directly responsible for correctly handling the memory being used. And what I mean by that is anytime you allocate memory, you delete memory, you're responsible for that. You have to tell the program how to manage it. When to allocate it, when to delete it, how to share it, who owns it. And as I talked about in the debugging lecture, most debugging issues or bugs in your program are generally memory type bugs. So if you don't do it correctly, you get memory leaks, seg faults, all that other fun stuff. So in order to correctly manage the memory, you have to understand the concept of ownership. In C++, you write these little classes and you write namespaces and all these fun things, and they all deal with the data, the memory somehow. And you have to decide who owns the data, who's in charge of keeping it sanitary, who's in charge of moving it, copying it, allocating it, deleting it. And it's important also to note that this discussion applies to other languages as well. So Fortran, you have allocatable arrays. You also have pointers. They don't get used as much in Fortran. In C, you just have pointers. You don't have all the fancy things that we're going to talk about today. So you have to be even more careful in C or Fortran. Although in Fortran, you should probably be using allocatable arrays as much as possible. Also, Python, for example, is a language that's garbage collected. I think Java is as well. But what that means is that there's a separate process running in the background, and he comes up behind you and says, oh, we're not using this anymore, we should delete it. And so that way you don't have to worry about it, but that has its own issues as well. But C++, you're in charge of everything. So the problems come when we start dealing with classes that have pointers in them. Okay, so I'm going to talk about a constructor. A constructor is a special function that is called by the compiler when an object is created. Whether you create it on the stack by saying my class A, or whether it's allocated on the heap through a pointer, the constructor is always called. It is the constructor's job to place the object in a usable state, or to birth the object. Okay, and that's the start of the object's lifetime. If you don't write a constructor, the compiler will make one for you. Okay. If you do provide a constructor, then the compiler will not make one. All right, so that's important to note. So here's my dumb little example. Here's what we have in our header file. We have we're going to declare we have a class. We're calling it my class. It has two private variables, a number of values, and then a pointer to those values. And we have a default constructor, which takes no arguments. And then we have a non-default constructor, which takes n here. Now, in the implementation file, this is probably how you do this. You say my class, : my class. And then you say the number of values is equal to 0, and we set the values pointer to a null pointer, which makes sense. Okay, we're going to say this is not pointing anything. We haven't done anything with it yet. However, in C++, there is a different way to do this, which is a little cleaner syntax. It's generally recommended to do it this way if you can. This is called an initializer list. So we start with the definition. I have a pen here. I should use it if it'll work for me. Yes. Okay. So we say this is our constructor, and then we have this little colon, and then we place our variables after this. And we say n vals will be 0, vals will be a null pointer. And that's called an initializer list. It's generally the recommended way to do things. I'm not sure exactly on all the details about that. Again, I'm not a C++ expert. I'm just a guy who reads a lot of Stack Overflow. So now for our non-default constructor, which is going to take a single argument, an integer, n. All right, we're going to use the initializer list to set n vals equal to n. And that gets done before we even enter the function body. Okay, so when we enter the function body, n vals has already been set. So that means we can use it. And we say our pointer vals is equal to new double array of n vals. Okay, kind of a dumb little class, but there you have it. That's my example. So on the opposite end, we have the destructor. And the job of the destructor is to perform any necessary cleanup when the object dies. So the interval between when the object is born and when it dies is the lifetime of the object. It's automatically called when the object is either deleted by the programmer using the delete statement, when the object goes out of scope, so if it's in a function and you leave the function, the destructor is called, or when the destructor of the class which contains this one is called. So if you have a class which has another class, if the parent class, I guess, the containing class, if it is deleted, then everything inside of it is also deleted. And so in many situations, and probably most situations, the destructor can be empty because it doesn't really do anything. And so if you don't write one, then the compiler will. And then the most important job of the destructor is to delete any memory that the object allocated. This is to prevent memory leaks. So a destructor has this funny little tilde symbol here followed by the name of the class. And this isn't technically correct because I forgot this here. I was making these slides really quickly. So anyway, so you can see we now delete our pointer. And if it's a null pointer, that still works. It's a no-op. It doesn't do anything if it's a null pointer, so that's safe to do there. So now, the copy constructor. The job of the copy constructor is to make an exact copy. However, this is where we start running into problems. So anyway, the copy constructor is called when the programmer explicitly calls it. So if you did something like this, if you had my class A, and then if you did something like my class B A, this line here would call the copy constructor. Now, whenever we pass an object into a function by value, or return a function by value, that will also call the copy constructor. And this makes more sense if you think of functions as being surrounded by really big walls. Anything declared inside the function or outside the function can't pass through those walls. So a copy has to be made, and that copy can pass through the walls. Or rather, the copy procedure. So if this is, let's say this is main, and this is your function, and we have an object here, and if we're going to pass this object by value into the function, then the function has a space reserved. Okay, let's say we just have a number 2. The function has a space reserved saying, here is where my object is going to go, and so the copy constructor then fills that object, that space up, so the function can now use it. And again, on the other side, the function actually has a special space for the return value. And that will then get copied out and back into main. And that's the extent of how far I can write, apparently. Okay. And so the copy process copies the values out of the function as well. Unfortunately, if we put all 3 of these things together, we can get problems. And I'm going to demonstrate that here. Okay, the next slide. Anyway, there's a couple ways you can declare the copy constructor. You declare it using a const reference or a non-const reference. In general, all you need is the const version. Okay. So here's our basic implementation. If we want to make a copy, we're going to copy n vals from the other one, or the right-hand side, and then we copy our pointer, vals. However, this does not work very well. Any ideas why? Ted might know.
We both have access to the same chunk of memory, right? Because you're passing a pointer to the whatever memory you're allocated.
Exactly. We haven't copied the memory. All we've done is copy the address of the memory. And so, here's an example. We have a function called useMyClass. We're passing this by value here, okay? And so here's my main function here. So we have A, and we pass A into the function. The function makes a copy. We're going to call it B, just so we're clear that these are 2 different things. This invokes the copy constructor, and then we go through the function, yada, 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 and when we hit the end of the function, notice when we're not returning anything, but the temporary value B goes out of scope. It's no longer needed. We're not inside the function anymore. And so this calls the destructor on B. And B deletes the block of memory that they are both looking at. So if this is A, and this is B, and here's the block of memory, A has a pointer to it, and B has a pointer to it. So when B goes out of scope, it deletes it, saying, okay, I'm done with it. Don't need it anymore. But A doesn't know that. Okay? And so A now has what's called a dangling pointer. It's pointing to something that doesn't exist. And if we try and use that memory, we'll get big errors. The operating system could catch it. It could not catch it. So If it does, we might get a seg fault. If it doesn't, we get garbage in our program. And then also, when the destructor for A is eventually called, you'll get a double free error because you're trying to free a block of memory that's already been freed. And that's where we need Valgrind. Or we just need to do this correctly. So this is how we actually do it correctly. We're going to set, so we copy n vals over, okay, and then we allocate memory for vals, all right, and then we actually copy the block of memory. So now this is A and this is B, all right, A is going to be, we're going to allocate an entirely new chunk of memory, and B has its own chunk of memory, and then we actually copy, hence the name copy constructor, the values. Now, I will say this, for sake of brevity, I didn't put a few things in here. First off, we have to do a check for if vals actually exists. If it's already pointing to something. So if vals is already pointing here, we can't just allocate this and make it point there, because now we've leaked this memory. It's sitting over here with no pointers pointing to it anymore. So you have to do a check, and that's pretty easy. All you have to do is say if, well, not vals. Now we can allocate it. If not, then we have to first delete the old memory, and then we can allocate the new memory. Okay, and you can get fancier with that kind of stuff. Another good check is check for self-assignment. What if I'd done something like this? So we have A here, and then we're going to say A. That's kind of ridiculous, but it can happen in situations. And so they always say you should check for self-assignment. And the way you do that is by saying the this pointer always refers to the object that we're currently inside of. And you just say if it's not equal to, I can't draw an ampersand, so we'll do a curly S, not equal to the address of other. So basically it's saying if these two pointers are not equal, then you can go ahead and do the copy. Otherwise, it's not necessary. Another thing is I haven't talked about and probably won't for a while is something called exception safety. We're not going to worry about that for now. Maybe we'll get to it later. All right. So now we have the copy assignment constructor. And this is a specialized copy constructor for the following situations, where we say A is equal to B or B is equal to C. Now what do we expect if we were to see that in our code? Any ideas, Yushi?
What would we expect if we just saw that in the code?
Yeah. What would you expect if you were just reading through someone's code and you saw?
Oh, what am I expecting it to do?
Yeah, what are you expecting it to do?
Copy the values of C, put them into B.
Exactly. That's what you're expecting it to do, and so that's what it does, or it's supposed to do. If you don't do it right, you can cause a lot of confusion because people will not understand what it's doing. And that's something that I had to get used to when I switched over to, or not switched, but when I started learning Python, because Python doesn't do that. They have more complicated rules. Anyway, so we can do this by overloading the assignment operator. Again, if you don't make one, the compiler will. And the assignment operator can take a lot of different forms. I just copied this list off the internet. But the generally accepted way to implement a copy assignment is through what's called the copy and swap idiom. There are other ways to do this. They all have their own rhymes and reasons. This method is simple, it's easy, it's exception safe if the copy constructor is also exception safe, and it reuses code. So the idea here is that we're going to pass by value. Okay, and so this calls the copy constructor. So we're reusing the copy constructor. At which point, all we have to do is swap. So this is a temporary value, which has made an exact copy of wherever it came from. And then we're going to swap the current object with the temporary object. Okay, and then the temporary object goes out of scope and takes everything with it, takes all the old data with it. So we don't have to do what I just showed you, which was all this delete stuff and all that other fun stuff. So, and swap is really easy to implement because there is a function called standard swap, which swaps two values. So that's really simple. And then you should always return a reference to the current object, because what that does is it allows operator chaining. You can say, if you want everything to be equal to D, then you can do A equals B, C, D. And that sets A, B, and C equal to D in one nice little line. All right, so now that we know all that stuff, we come to the rule of zero, which is if your class is simple and doesn't own or manage anything, don't implement anything and let the compiler take care of it. Okay? It saves you time, it saves you mistakes. And in C++11, you are allowed to make this explicit by actually declaring them as all default. It tells the compiler, I want you to handle this. This is generally recommended because it makes your intentions clear. It's not that you just forgot it. It's that you said, I want the compiler to take care of this. And it is possible that maybe you don't want your class to be copied. Maybe it has a ton of data in it and you don't want to have to copy all of that. And so you can either make the copy constructors private, in which case the compiler and anybody else can't use them because they're private to the class, or in C++11 you can explicitly delete them. Okay, and you can see here I've done both, which is kind of redundant, but there you have it. So again, that's more explicit. It's not just a mistake. I'm saying I want these deleted. You cannot copy my class. All right. So if we have the rule of 0, then we have the rule of 3, which is if you have to declare any one of them, the copy constructor, the assignment, or the destructor, then you should implement all three. And what this does is it forces you to consider all aspects of your memory management and get it right the first time. It prevents you from making mistakes. Alrighty. So now we're going to talk about L values versus R values. So an L value is something which is allowed on the left side of an assignment operator, while an R value is not allowed on the left side of the assignment operator. For instance, if a function returns an object, that is an R value because it would be ridiculous, again, to try and assign something to it. So Yushi, I know you're not as familiar with C++, but I want you to take a look at this line right here. Does that look right to you?
A has 20. New object is only going to have 15. No, it doesn't look right.
Why? Well, not that the numbers are different. Maybe that's a red herring. Any thoughts, Ted?
Get new object, it like returns. How would I explain it? It looks like like something that would be on the right hand side of an equal sign.
Why? There's some vague reason why. Any thoughts, Ted?
I've read stuff on R values and I'll get values a few times, but I always forget. Like,
It's a confusing topic, first off. It's C++, so everything's confusing. But here's the reason why it doesn't make sense. You know it doesn't make sense, but you can't say why. It's because get new object, how are we going to find it after this? If we want to use this later on, how are we going to find it? How are we going to address it? What is it called? Okay, so it's kind of ridiculous for it to be on the left-hand side because that's saying that we want to use it later. We want to store it and keep it around. Does that make sense? So, there are a couple of ways to think about this. An L value is something which has a name. An R value does not. Another way to think about it is that R values are temporary variables which are right about to die. All right. Another important note is that L values can be passed by a non-const reference, while R values must be passed by a const reference. And I can explain that in a little bit. But here's this same line here. Okay. And then I added this line here. The third line there makes more sense, right? Because A is an L value. It has a name. It's called A, and we can use it later on. While on the right-hand side, we have, in fact, in this function even, it doesn't have a name. We never gave it a name. We just said make a new object and return it. We could have said something like this. All right, so now it has a name, but what's the problem with this? Why is this still not an L value?
because it only exists in the scope of that function.
Exactly. In the scope of the function, it's an L value, but once we leave the function, B is going out of scope. It only lives long enough so it can be copied out of the function. And so it's about to die. So we're going to call it an R value, even though inside the function it's actually an L value. So it all depends on the scope you're talking about. As far as a const versus non-const reference, so if we had a function that took so you see, no. Let's actually go back. Where did my, was it in here? No, it wasn't. Never mind. Okay. So let's say we have a function. Come here, screen. We have a reference here. Oh, I did it. Would you look at that? Now in C++, they have some rules on what you can pass to a function Oops. All right, so here, this one is non-const, meaning we'll be able to modify it. This one is. So what would happen if we called this function like so? I guess I should make this easier for you guys to see. All right. So if we called the function like that, what's it? And let's say we wrote first off number 1 here. What's going on here? We have an R value. We already talked about that. It doesn't have a name, and we're passing it by reference into the first do something function here.
It's just like what we were trying to do before, where we were trying to assign A to the get new objects, like, except you're just doing it inside the function. Like you try and modify it. This makes sense.
Exactly. It doesn't make sense because we have a reference to something that doesn't exist anymore. It's dead. It's gone. But the rules say that you can pass it by a const reference because we're not changing it. We're not modifying it. Okay, so it's basically taking a picture of what it did look like and storing that for the use of the function. Does that make sense? So you can pass these by const, and so it's generally best to make things as const as you can. So that way, people can do things like this rather than having to save a temporary variable to pass it into your function. Okay. So before C++ 11 came out, they really only had an L value. But now, after C++ 11, they've formalized the notion of what an R value is and allows the programmer to actually manipulate them. And the whole point of this is to allow what is known as the move constructor. And so the move constructor job is to move resources from an R value to an L value without doing all the copying. Okay, it's a performance optimization. And so it takes two different forms here. Generally, for this, you don't want a const case. You want to use the non-const case, and I'll show you why later, or on the next slide, I guess. So the job of a move constructor is twofold. It moves ownership of resources from the R value to the L value. And then the second thing it must do is place the R value in a state where it can be deallocated correctly without damaging anything. And so here's an example of this. First off, we're going to copy inval from here to here. And then we copy just the pointer. And so this is if this is A and this is B, B points to here, okay? And then we're going to say, all right, A, tell you what, you point over there, and we're going to delete your pointer. So that way, once B dies, it doesn't worry about anything. But we didn't actually have to make a second copy again and copy all the resources, and that saves time and money, probably, since time is money. And so that's the first job. The first two lines are the first job, and then the second two here set the other one to a default state where it can be deallocated properly by the destructor, I should say. So if there is a move constructor, then there must be a move assignment. However, what's really nice is that if you use the copy and swap idiom, which again, there are reasons not to do this, but if you did that, then there is no need to write a move assignment operator. Any ideas why? So the copy and swap, what it does is it has an assignment operator that takes an object by value. And so that right there implements the copy constructor. However, if you're dealing with an R value, the compiler's smart enough to use the move constructor instead. And it moves the R value into this L value, at which point you do your nice swap, and all the dead old resources get thrown out with the temporary variable. All right? So anyway, this is an example of a move assignment that you could write if you needed to. And note you always have to take into account first for self-assignment, you need to delete any old resources, and then you need to move the old resources and default initialize the temporary or the R value. And so that is the move assignment constructor. So then there's the rule of 5, or some people say 4, but it's about the same thing. If you have to write one of them, you have to write them all. Okay? And that you don't have to. There's nothing in the C++ language that says you have to write them, but it's a rule of thumb that you should follow. And you should also make sure that they do what they're supposed to do. I mean, you can write them to do whatever you want. You can write them to count pigs. You can write them to, anything you want. But this is what they were made for. This is their job, and you should write them to do that job and nothing else. Anyway, so that actually didn't take as long as I thought it would. But you have any questions on any of this? Make sense? Okay. I know they probably covered a lot of this in CS classes, but we're engineers and we don't take CS classes. So I've dealt with engineers who don't do this correctly, and Ted has too. And it causes headaches and memory leaks. There was a memory leak in one of my codes during my master's thesis, and I was right in the middle of everything, super stressed, and I had this case running for days on end, and I come back to it, and it had spit out a big error. Operating system killed your program because operating system ran out of memory, thanks to a memory leak. So, this is really important to understand. This is obviously just the basics, but it'll get you going in the right direction. So, anyway, that's all I have for you guys today. I don't have any more slides. I was going to keep making them, but I ran out of time. So, we'll cover that later. Cover the rest of it later. Anyway, again, email me if you're having problems with the project, and good luck.